Okay, dear colleagues, first of all, I would like to thank Natasha, Anna, and Tamás for giving me the opportunity to participate in this special event. So, during my presentation, first I will speak about the production challenges in cellular titanium 3D printing. And after that, I would like to introduce the newest cooperative project between the University of Debrecen and University of Belgrade. So, why do we use cellular titanium? Titanium have several excellent properties like biocompatibility, high specific strength, and corrosion resistance. That's why we use titanium for biomedical applications like implants and the cellular structure, especially in the case of implants, enables the structure to the osseointegration. That means that the bone is able to grow inside the structure of the metal, the structure of the implant. So really high strength, really strong connection will be formed in this way. There are several kinds of technologies for titanium 3D printing. This one is the laser powder bed fusion, when we use laser to melt the titanium particles. Another technology is the so-called it has some noise, sorry. Maybe. Okay, so in the case of direct derivative application, there is a ratio head with the titanium powder feeder, and it contains the laser that will melt the powder. It is something like melting in this case. And the third method that is commonly used is the so-called electron beam melting, when an electron beam will melt the titanium powder in a heated chamber and in a vacuum environment. So it is will be different from the powder bed fusion, because in the case of powder bed fusion, we use inert gas like argon or nitrogen to eliminate the oxidation during the production. So I don't know how to hide this one, but maybe we can see.
I think it will go away with itself. No, not this one. Upper.
Upper?
Yes.
Ah, this one. Oh, no.
That's what it is. Yes. I think that should remove itself after a little while.
Okay, maybe I can continue using this new way, because there's no other video or something. Like
okay, yes, and then when the video is done,
it's better. Okay.
yes.
Okay, so comparing these kind of technologies, we can see that the powder bed fusion or direct metal laser sintering are the best technologies for creation or manufacturing lattice structures because of the very high resolution capability of these technologies. So let's see what kind of challenges we can face during these technologies. The first challenge is the geometrical accuracy. When we experience that the design, the 3D geometry is not the same as the printed geometry. The key issues in this case are the strut thickening, undersized pores, and edge rounding. And the causes of these are the melt, pool, spreading, partially fused particles, and thermal accumulation. So the partially fused particles, like here we can see, cause other problems like raw surface that cause crack initiation and poor fatigue life. The next challenge is the residual stress and distortion because of the heat, because of the very high temperature during the laser melting. These problems especially can be experienced in the case of thin struts and unsupported overhangs. Another problem with these kind of production technologies is the support design and removal. So in this case, we can see some structures, some lattice structures here, and the support itself can be seen at the bottom of the specimens. In this case, it is not really hard to remove, so we can use a saw machine to cut the support, but in the case we have to remove the support inside the structure, inside the model, inside the specific part. It is really hard and cause much problems. And the last challenge, according to the 3D printing of titanium, is the post-processing complexity. After the printing, we have to remove the powder from the structure, from the parts, and it causes some serious problem in some cases. And after the powder removal, there is heat treatment and surface finishing. These are really cost and so the high cost and in time and in money as well. Okay, so summarizing these problems and the solutions for these problems can be seen here. So we can apply process optimization, design optimization, and digital validation to eliminate these kind of problems, these kind of challenges. And using advanced post-processing, we can automate the finishing process and eliminate the last challenge I mentioned earlier. Okay, so that was about the challenges, and now I would like to mention our own problems and our own project in this case. So in University of Debrecen, we have an EOS M290 machine. This is a direct laser metal sintering machine with these parameters here. We have a recent project cooperating with the University of Belgrade, when we would like to develop bone plates with lattice structures. Bone plates can be seen here. The function of the bone plates is to fix the ends of the bone during the fusion process, and after that, generally these implants will be removed. But in some cases, it is better to leave these implants inside the body, and in these cases, it would be useful when the structure of the implant could be lattice structure, so the osseointegration, the bone growth can be realized. So we made some specimens, and we faced the above mentioned problems, like the geometrical problems. So we are on this project, we are at the beginning of this project, and maybe next time I can show you our results on the project. Thank you for your attention.